Hello students, welcome to Hari Chemistry. So myself Dr. Hari Prasad. Today's session we will discuss student organic named reaction series lecture we will discuss right. So in this series of lecture students we will start with the Wurtz reaction first, then followed by some other reaction. Today's session we will finish right. So please subscribe my channel student, and please like the video and share to your friends. Thank you. So Wurtz reaction is student alkyl halides react with sodium metal in presence of dry ether gives alkane as a product right. Okay, so Wurtz reaction students mainly it is useful for the symmetrical alkane right. So preparation of symmetrical alkanes, preparation of symmetrical alkanes, preparation of symmetrical alkanes. In this reaction student, so here we will take alkyl halide. So you can take 2 moles of alkyl halide, or you can take Rx plus you can take 2 moles of sodium plus take 1 more alkyl halide in presence of dry ether student. In presence of dry ether, so you will get alkane is the product and formation of sodium halide. This is alkane student right. Now look at student. So in this reaction, so we are using dry ether is a solvent. We are using dry ether is a solvent right. Now look at student. So why we are taking dry ether as a solvent right? Okay. Now look at student. So if we take moist ether, so that what will happen student? This sodium metal react with water and form NaOH right. This NaOH student, this react with this NaOH react with alkyl halide. So then student formation of alcohol is the product. And one more thing student, sodium react with water. So maybe the reaction maybe takes place explosive also. That's why students we need to take always dry ether is the priority right, for the preparation of alkane. Right. Now look at student, this reaction is also called as a carbon-carbon coupling reaction because this R group, this alkyl radical is combining with another alkyl radical, so that undergoing dimerization process. Then in this dimerization process, carbon-carbon coupling reaction is takes place. Now we will see the mechanism of this reaction student. Like now look at students, we are using sodium metal. The sodium metal is a very good source of electron source student. So because this first group elements are S block elements are very good source of electron. So because of this first group elements having the low ionization potential energy. So low ionization potential energy, Na plus electron. Right. Now this Na plus ion is surrounded by solvent diethyl ether. So ether. Now look at student. So this is positive, negative. So generally this is a solvated of ether. Then student it is converted into solvation energy. If water we are using as a solvent, generally we will call it is a hydration enthalpy. But here we are using any other solvent student, generally we will call it is a solvation. So in this process it releases solvation energy. This solvation energy is converted into activation energy. Usually this reaction is student exothermic reaction only. It will release the energy in this process. Right? Now this electron reacted with alkyl halide. Student. It is followed by the free radical reaction student. Now this will be leave and this electron shifted here, then it will form R radical student. Now this R radical is undergoing dimerization process dimerization process, then it will give alkane as a product to student. It will give alkane as a product to student, right? Now look at students, we will discuss some example, then we will get the idea, right? So this is a free radical undergoing, this is a free radical, so this is called alkyl free radical, student. So this alkyl free radical undergoing dimerization, alkyl free radical undergoing dimerization. Now look at the some reaction, student. So ethyl chloride reacted with sodium in presence of dry ether, student. So usually we will get the product is N-butane is the product to student. N-butane is the product, right? Now we will check the mechanism of this particular reaction, student. So generally sodium we are using. So sodium is a very good source of electron, student. So due to the low ionization potential energy, right? Now this electron is reacted with ethyl chloride, student, right? So this ethyl chloride, now this bond will be cleaved. Now this electron will be shifted, student. So it will form ethyl radical as well, right? Now this ethyl radical and combining with another ethyl radical, so then it will form so butane as a product to student. It will form a butane as a product, right? Similarly, look at student. So this particular reaction, so this will coupling with the cyclohexyl chloride in presence of dry ether, student. Sodium dry ether, we will get cyclohexane, or you can write dicyclohexane, we will get it. In this reaction also, student, the same process, student. So now this is the sodium metal, it is a very good source of electron. So due to the low ionization potential energy, right? Now this cyclohexyl chloride, this is the cyclohexyl chloride reacted with this electron, so then it will form a cyclohexyl radical. It will form a cyclohexyl radical. Generally the free radicals are highly reactive, students. Their activation energy will be very, very low, right? Now this cyclohexyl free radical undergoing dimerization, so give student, so this is the dicyclohexane as a product. Right. So this is dicyclohexane as a product. Now look at student. So this is the general reaction, student. So we will discuss a very important point for this Wurtz reaction, student, right? So the first point, students, the very important point is methane cannot be prepared by Wurtz reaction, because generally coupling is going on, takes place during, because these alkyl free radicals are going combining dimerization. So that's why, so at least we will get the lower molecular mass of C2H6 is the possible product, right? Okay. So that's why methane cannot be prepared by this particular method, right? Okay. Lowest molecular mass of alkane we can prepared by this Wurtz reaction, student. So for example, if we have methyl chloride, this methyl chloride reaction with the sodium in presence of dry ether, student. So we will get ethane is the possible product, student. So this is the very right, this is the starting material for the formation of a alkane during the Wurtz reaction, student. This is the compound which is having the lower molecular mass only, right? Lowest molecular mass. So beyond that we cannot prepare it, because at least we can prepare at least 2 carbon atom linking only, right? So methane we cannot prepare by this Wurtz reaction, right? Now look at student. The third point, student, if we have 2 different alkyl halides on reaction, it will give 3 different alkanes as a product, right? Okay. Now look at student. So if we have alkyl halide RX, R-X, right? Now what will happen, student? So generally the reaction, if you look at the mechanism process, this Na will undergo Na plus, student, then it will form electron, right? Now this electron reacted with Rx, so then it will form, student, R radical. Similarly, this will react with R-X with electron, so then it will form R dash, student, right? R dash radical. Now, so if R radical undergoing dimerization, then we will get, so this is a RR coupling. Okay. Now if R dash radical and R dash radical undergoing coupling, so then we will get R dash, right? Now if R and R dash are going dimerization, so this is the cross coupling, so then we will get this product right now. So if we have two different alkyl halides on reaction, student, we will get the three possible of alkanes, we will get this Wurtz reaction. Right? Now look at, student, for example, if we have methyl chloride on reaction with ethyl chloride, the two different alkyl halides on reaction in presence of dry ether using the sodium metal as a source of electron. So usually, student, so it will get a methyl radical. So this will be sodium plus undergoing loss of electron, so it will form electron. So this methyl chloride reacts with this electron and it will form a methyl radical as a product with the methyl radical as a product plus Cl minus, right? Now this Cl minus will combining with Na plus and formed as a product of NaCl, that is the another thing. Similarly, student, this C2H5Cl also reacted with this electron, then it will form C2H5 radical. Now, so if methyl radical and methyl radical undergoing CC coupling, then it is dimerization, we will get ethane is the product. And each C2H5 radical undergoing dimerization, so then, student, we will get the butane is the product. Now methyl radical and ethyl radical undergoing combination, student, dimerization, so we will get propane is the product. This is a cross coupling product, right? Now similarly, student, the fourth point we will look at the rate of Wurtz reaction, student, alkyl iodides. So Ri is greater than, Rbr greater than, RCl greater than Rf, right? Okay. So I minus is a very good living group compared to other bromine, chlorine, alkyl bromine and alkyl chloride and alkyl fluoride. So I minus is a very good living group, right? So this group leaves and alkyl radicals undergoing dimerization process. So therefore this Wurtz reaction, student, if I minus reaction, I minus will be there or Cl minus will be there. So generally I minus will undergoes very fast reaction, means rate of reaction will be very high. Okay. Now fifth point, student, even carbon alkane obtained in high yield rate. So even carbon of alkane obtain high yield rate. So for example, if I am writing, right, for example, this is the N-butane. Now N-butane, student, so if I use, this is the starting material, ethyl chloride plus ethyl chloride. So there is no other possible product, student. This ethyl chloride and ethyl chloride reaction with the sodium, student, in presence of dry ether, so we will get the maximum product of is only butane only. So we cannot get any other byproduct. So that's why, so this Wurtz reaction, student, especially symmetrical alkane, high yield possible for only symmetrical alkane using. Now you people have one more doubt also. Sir, can we use methyl chloride and propyl chloride? Yes, you can use methyl chloride and propyl chloride also you can use. Then you will get the different type of products. You cannot get only one product, right? But if I use a ethyl chloride and ethyl chloride, if you are using the symmetrical alkyl halide, then we will get the high percentage of yield during the Wurtz reaction process. Right? Now, look at, student, for example, if I want to make ethane, so then I will use the methyl chloride plus methyl chloride. These are the starting material. So using sodium in presence of dry ether, so then I will get the high yield of ethane is the possible product, right? Now for example, if I want to prepare hexane as a product, right? So student, your alkyl halide will be symmetrical only. Your alkyl halide will be symmetrical means you can take propyl chloride plus propyl chloride. So if you take propyl chloride plus propyl chloride only, if you want to prepare high percentage of yield of product, then you can take CS3, CH2, CH2, Cl. Right. Now you need a symmetrical alkyl halide, then it will give the high yield product only. You can ask a doubt also, sir, NHCN we are preparing by using propyl chloride, why not any other material? Yes, you can use ethyl chloride and you can use butyl chloride, right? So you will get the product, and you can use the methyl chloride and pentyl chloride, you will get the product, but so it undergoing cross products or possibility takes place, right? It undergoing that too many byproducts will come. So too many byproducts are coming, automatically the main product yield will be very, very less only. So that's why even carbon alkane obtained high yield. But the very, very important thing is, student, the high yield possible for symmetrical alkanes using the identical alkyl halide is the required. So then only it will give the high yield product item. Now odd carbon alkane obtained in low yield only. Odd carbon alkanate, for example, I want to prepare methane. So if I want to prepare methane, student, so I need propane, then I need methyl chloride and I need ethyl chloride, right? So if I use only methyl chloride, it is identical, I cannot get the propane. Okay. So if I use only ethyl chloride as identical, then I cannot get a propane, I will get the butane. So in this particular reaction, student, we need two different alkyl halides only. Then only odd number of alkane is obtained in a low yield. Because of this methyl radical will undergoes dimerization, it will give ethane as a product. And ethyl radical and ethyl radical undergoing dimerization, then it will give the butane. And ethyl radical and methyl radical undergoing dimerization, it will give, right? So here this is the propane is obtained as a product, but it is the combination of other byproducts also, right? The contribution of byproducts also possible along with the main product only. So that's why, student, odd carbon alkane obtained in a low yield only, right? Now for example 1, 2, 3, 4, 5, right? I want to prepare a n-pentane. So n-pentane, I don't have any identical alkane for the preparation of this odd number carbon alkane, right? So for example, in this particular case, I need CH3CH2Cl and I need CS3CH2CH2Cl, right? I need propyl chloride and I need ethyl chloride, right? So then what is happening, if I use the ethyl chloride, it undergoes dimerization, it will form butane as a product. And this propyl radical undergoing recombination, it will give the hexane is the product, right? Then ethyl radical and propyl radical undergoing combination, then only I will get the pentane is the product, right? So now look at, student, if I want to prepare a odd carbon alkane, then automatically I am getting the low yield only, because here it is contributed with the butane and hexane as a byproduct. So this contribution along with that original molecule, original compound only takes place. So that's why here we will get the low yield, right? Okay, now, right. Now, 7th point, student. So free radicals are highly reactive and its activation energy is, some books given as a 0 only. So, right, activation energy is not equal to 0, student. Generally, the activation energy will be low, so it undergoes coupling reaction. So, due to the activation energy is very low, but they are highly reactive, then it will undergoes combination. So then it is undergoes thus methyl radical undergoes, and alkyl radical undergoes combination, and it will form a ethane is the product, right? 8th point, you can check it, student. So free radical can undergoes disproportionation reaction. So disproportionation reaction means one undergo the same compound undergoing oxidation and same compound undergoing reduction, student. Generally we are calling it as a, right? So in this particular, student, so it undergoing disproportionation. So disproportionation reactions are not possible, student. So generally we observed as not as a major or not as a minor, we observed as a trace amount only, right? So disproportionation is observed in a trace amount. It is not as a major or it is not a minor, right? Okay. So now look at here, we have a ethyl radical and here we have a ethyl radical. This ethyl radical is, right, abstract the hydrogen, then it will form ethane as a product, right? So this is the 13 electron system, student. Carbon 4, valency electron 8 plus 8, 4 plus 4, 8, 3 from hydrogen, 2 from, then it is a 13 electron system. Now then it is converted into 4 plus 4, 8, 8 plus 6, 14, right? Now look at, student, this hydrogen is abstract here, then this hydrogen and leave, right? So homolytic cleavage is possible. Then it is free radical and free radical, right? This radical combining ethane possible. Now this radical and this radical, right? So then automatically what will happen, student? Radical undergoing recombination, then we will get the ethene is the product, right? So free radical can undergo disproportionation reaction, student. This is not a major and it is not a minor, it is the trace amounts we observed in this Wurtz reaction process, right? Generally, student, the disproportionation reactions are possible especially in this tertiary butyl radical case only. If this tertiary butyl radical case undergoing dimerization, so we will get this type of compound. So means undergoing recombination, carbon-carbon dimerization possible. But generally this particular type of tertiary butyl radical student, disproportionation is the major product item. Now, so this is, you can write student, this will be CH2 and hydrogen radical you can combine. This hydrogen radical is absorbed by something. So then this bond will be shifted. You will get the isobutylene is the product. You will get the isobutylene is the product item. Now similarly one will be student isobutane is the product item. So in case of, for example, just you can go through, right? For example, if I write as same as previous example, right? Now look at student. So this is a CH3. So this is, can I write student CH2, right? Right. Now look at students. So can I write this is CH3. This is CH3 and C radical. This will be CH3. Now look at student. This free radical is combining this. So it undergoing homolytic cleavage. Now this radical recombining, and this radical it reaction takes place. This will be form a double bond here. So then I will get student CH3 C CH3 double bond CH2. This is isobutylene, this is one product. And one more, look at students, we will get the product is, this will be CH3, CH, CH3, CH3 is the product. Now this is the one product we will get, right? So this disproportionation reaction possible student, that is only in case of tertiary butyl radical, and it is we observed as a trace amounts only. Next student, right? Now look at students, some example we will discuss. So this ethyl chloride on propyl chloride on reaction student. So we will get student. So this will be, right, radical formation takes place. This radical and recombining student. So we will get hexane is the product, right? Similarly, look at student. So this is the radical, and this radical and radical recombining student, we will get the product like this. Now look at students, we have ethyl chloride and propyl chloride student using the sodium diether. So this is the two different alkyl halides we have. We will get the three different products student. So one will be N-butane is the product. One will be propyl chloride, means N-hexane is the possible product. And one cross product will be student. So pentane is the possible product item. Now similarly, look at students, we have cyclohexyl chloride and methyl chloride. So it undergoing, what is the reaction using the sodium in presence of dry ether student. So two different alkyl halides are there. So then I will write the possible product student. So two cyclohexyl radicals undergoing the coupling student, we will get the dicyclohexane. And so methyl radical undergoing coupling, and we will get the ethane. And methyl radical and cyclohexyl radical undergoing combination. So then it is undergoing the cross coupling, then we will get the, so cyclohexyl methane, right? Right. Now methyl cyclohexane. Now similarly, look at student. So this is, if any unsaturated bonds are present student, maybe I think delocalization possible, right? Now look at student. So for example, so if it form double bond, and here we have a radical, right? Now, so possibilities here I will write student one more possible. This radical will combining, then we will get student, this is also possible. Now look at student, this radical undergoing recombining, then we will get the product to student. This is the double bond I will write, right? So this is one possible student. Now this combining undergoes student. So this will undergoing combination. Now this is the double bond I am writing. Now look at student. Now this is, right, now the bond will be like this. Single bond after like this. Right. Now look at students. So this is the possible product, right? Now if we have isomer carbon is there. So C14 isomer carbon is there. So this radical undergoes resonance only. Now look at student. The possible product I will write student. So now look at here. This is C14 we have. Now this is the radical. Now this undergoes student, formation of a product is, this is the radical. Now this undergoes combination student. Now we will get the product. Now I will write like this. Now student, this is 14 and this is 14. Okay, this is one possible product. Now similarly you can check it, students, with the help of this. Now look at, student, I will write like this. This is the radical right. This is the double bond. Now this radical. Now this is C14, I will write. This is the C14. Again you can write, student. So just for the clarification here I am writing, student. For the clarification I am writing. So for example, if we have a C14 and this is the double bond. So this is C14, student. Right? Now just you can connect these, student. If you connect these, student, right, now this is okay, this radical, right, now can I write, student, this will be combined and this is my double bond and this is the C14. Okay, and one more possibility also there, student. This will undergo recombination, these two cross. Now I will get the product, student, you can check it. This will be, now this is radical, this is a C14. This is a C14 radical, student. C14 plus this will be, look at, student. This will be, so here I can write, student, this is the radical, for example, you can take. This is the radical, for example, you can take. Just you can look at this. Is right. Now this undergoes combination. Then we will get the, so here we have a C14 here, students. So this radical only we have a 14. Right. Now look at, students, we will get the compound is like this. We will get the compound is like this. This is the C14, student. Now look at here. Now this is the possible product. So this is 1, this is 2 and this is 3, right. Now the 3 possible products are out. Now look at, students, so we have cyclopropyl, cyclopentyl chloride and cyclohexyl chloride. So 3 different are there, student. Right. Now we will get one product will be, so this undergoing dimerization. And one more, student, this cyclohexyl undergoing dimerization. And one more possible, student, cross coupling. Right. Now similarly you can try, student, we have a 3 different alkyl halide. So if you have a 3 different alkyl halide, students, generally possible products are 5. Why? Because methyl undergoing coupling, then we will get ethane is the product. If propyl chloride, ethyl chloride undergoing coupling, student, we will get butane is the product. Propyl chloride undergoing coupling, student, we will get so hexane is the product. Right. These 3 are possible. Now similarly, if ethyl chloride, methyl chloride undergoing cross coupling, generally we will get, student, propane is the product. Now ethyl chloride and propyl chloride undergoing coupling, so we will get the pentane is the possible product. Right. Now propyl chloride, methyl chloride undergoing coupling, then we will get again butane. Right. So then possible number of products, if you have a 3 different alkyl halide, student. So if you are using a 3 different alkyl halides, student, so we will get the possible number of products 5. Okay, na, student. The 9th point you can check it, student. In Wurtz reaction, the mainly combination reaction takes place. Major reactions are combination reactions only. Disproportionation reactions we observed as a not major or not minor, we observed as a minor only. And this via free radical followed by the SN2 mechanism. Okay, right. So steric hindrance is direct deciding factor for the rate of reaction. So means rate of reaction is inversely proportionality to steric hindrance, right. So if more bulkier groups will be there, then automatically rate of reaction will be decreases, right. So order of reactivity of alkyl halide, students, 1 degree methyl halide, 1 degree alkyl halide, 2 degree alkyl halide, 3 degree alkyl halide. So 1 degree alkyl halide rate will be faster than, right, a methyl halide reaction rate of reaction will be faster than 1 degree, than 2 degree and 3 degree. So this point is important, student, just you can revise the point, right? Next, and in this Wurtz reaction also, student, two types of reactions are possible. One will be intermolecular Wurtz reaction and one will be intramolecular Wurtz reaction. Generally, if we have only one monohalogen, right, generally it undergoes intermolecular reaction, student. Whatever the reaction we studied from starting, student, these all are intermolecular only. But intramolecular Wurtz reaction takes place polyhalide, means more than one atom will be there. So in this more than one atom, student, for example, if I have a 1-2 positions or dihalogens are there, so generally it will form a open chain compound undergoing unsaturated product is the, or we can called acyclic product is the, acyclic is the major product, right? For example, 1,3 means that halogen positions are not 1,2, it is greater than 1,3 or 1,n, right, like that. So then it undergoes, student, cyclization process, right? Okay. So if single halogen is present, student, it undergoes intermolecular Wurtz reaction. Generally, intramolecular Wurtz reactions are intramolecular Wurtz reactions are, student, very important, student. So generally in this intramolecular Wurtz reaction, student, the entropy of the reaction will be increases, right? Now look at, students, we have 1,2, right? So this 1,2 dihalogen is there, student, it will undergo, student, so this radical combination will takes place, student, right? Now it will form like this. So because this will form a radical and this will form a radical undergoing recombination, then it will form this type of product, right? Now look at, student, for example, if we have, so 1,3 position, right? So now if we have a 1,3 position, student, right? So this intramolecular reaction is faster because increase in entropy, right? Now for example, student, actually we will get the first product is this product, student. So this is called benzene also. This is called, one of the structure of benzene was given by Dewar. So this is the Dewar benzene. It is a highly unstable only. This is also one of the structure of benzene, student. This structure was given by Dewar scientist. So it is a highly unstable only. Then you can go for the rearrangement, right, resonance process, student. So we will get the Kekule benzene is the major product. So then finally we will get, student, Kekule benzene. So Kekule benzene is highly stable only. This is the accepted model. Dewar model is not accepted model. It is highly unstable only. Now similarly, students, we are using, so ClBr, student, right? So first it will lose Br radical first, then Cl radical, then it is undergoing combination, student. We will get the product is like this. Right. Now look at, student. So if we have chloro, this is the PYQ question. Chlorobromide is there, student, right? First it will leave bromide, then it will form a radical, then after it will leave chloride radical, then it will form, right? It is not a cyclopropyl, student, it is a sigma bond only, right? So it is a sigma bond, it is exothermic ring, the strain compensated by sigma bond only, right? For example, if it is a X, generally this formation of this process X plus 20, right? Then the formation of sigma bond, this energy is compensated, that is 100 kilojoule per mole. Then X minus 80, right? So means here the ring strain is predominated by this sigma bond only, right? So that's why these reactions are feasible only, right? And stable only, right? Now look at, student. So this is a ClBr, student, right? In this particular case, student, ClBr. Now look at the example, student. So here also it will form radicals here. Now this is the radical and this is the radical. So this radical will form, student. First it will be Dewar benzene, right? So again it undergoing, student, right? Or else you can do one thing, student. So this undergoing homolytic cleavage, then it will form, student. Look at here. So this will be double bond here, I will write. Now this free radical and free radical, and this free radical and free radical. So then, student, we will get the compound benzene is the possible product, right? So benzene is the major only, this is the Kekule product. So this is the Dewar product. So this Dewar product is student highly unstable only. Similarly, look at student. So this compound and reaction with Wurtz reaction. So look at students, we will get the product is, now this will be radical, this will be radical. Again undergoing resonance students, so we will get the product is like this. So we will get the naphthalene is the product, right? Similarly student, look at here this compound, right? So just you can break this here, you can form one radical here and you can form one radical. So here you can form radical and you can form radical student. So we will get the product is, final product is like this. We will get the product is like this. Just you can join student, right? Now you can join like this, you can join like this. This is the possible product. Okay, right? Now similarly students, you can use this compound student. So this form a radical, right? So again you can write student one more compound as like this. Now these radicals are recombining student. So we will get the compound is like this. We will get the compound like this, right? Now look at student. So this is 1 comma 1 2 3 4 5 compounds are there student, right? 1 comma n position student. So here it will be one radical and it will be one radical student. So generally it undergoing. So you can write like this student, right? So for example you can write this is a Br radical and this is 1, this is 2, 3, 4, right? So and you can write student 5. So 1, 2, 3, 4, 5 and you can write Br student. So now you can make one radical here student. You can make one radical here. So you can make one radical here. Just you can recombining student. So then we will get student. So cyclopentane is the product. So means it undergoing cyclization, right? Similarly look at student. So this is radical we will write. So now this is radical. Now we will get the radical here student. Now this is the radical. This is the CH2 radical. And look at student. So this is our CH2 radical, right? Now this CH2 radical undergoing recombination student. So we will get the product is like this. We will get the product is like this. Similarly look at student. So this compound. So this is the radical. Now this is the radical student. Now this is the radical. Now this radical recombining. So we will get 1, 2, 3, 4, 5. So a 5-membered ring we will get student. A 5-membered ring we will get. A 5-membered ring we will get. So this is the possible product student. I hope this is about Wurtz reaction student, right? So please watch the video and like the video and share to your friends. Maximum Wurtz reaction at extent level I covered student. So thanks for watching this video. So Wurtz fatigue reaction student. So in this Wurtz fatigue reaction students, Wurtz and fatigue reaction student, if one of the reactant molecule is alkyl halide and that is Wurtz and another is aromatic halide, so then it will form student alkyl aryl halide. So alkyl benzene type of compound student. Alkyl benzene type of compound, right? Aryl alkane type of compound, right? Now look at student. So this will form a alkyl radical and this will form a phenyl radical and this will combining student. So it will give the product is student. So this is R, right? For example, you can take student. For example, this sodium will undergo student. So this sodium is a source of electron. So we are using the dry ether is the solvent. So then it will form electron. This is reacted with RX student. Then it will form and this will form a R radical. So similarly student, so this is a PHX. So electron, right? So this will leave and this will be, right? Then it will form student PH radical. And this PH radical and R radical will recombining, then it will form student aryl alkanes as a product. Now similarly student, so this is right? So this Cl radical, CH2 radical, this is not possible, student. Some rotation is possible, student. So I can write this rotation and I will write the product, student. So now look at, student. So this is the radical and this will be CH2 radical. Now this will combine, student. This will combine and formed as a product is like this. Right. So a 5-member ring is possible, student. This is a Wurtz-Fittig reaction, student. Wurtz is alkyl halide, Fittig is aryl halide. So in presence of sodium diether, student, we will get aryl alkanes type of compound or alkyl benzene we will get, student, right? Next, Fittig reaction, student. So Fittig reaction, students, if both reactants are aromatic halides only, right? So then this aromatic halides reaction with sodium in presence of dry ether, student. So we will get, student, so biphenyl we can call. So it is a diphenyl or we can call diaryls. So this is called, student, biphenyl. This is called biphenyl or diaryl compounds. So this is, student, Fittig reaction. So difference between Wurtz-Fittig and Fittig reaction, student. Wurtz reaction is only aliphatic aldehydes, aliphatic aldehydes. Wurtz-Fittig reaction is, student, aromatic halide plus aliphatic aldehyde, aliphatic halides. Fittig reaction, student, only aromatic halides undergoing dimerization, right? Then Ullmann reaction, student. So Ullmann coupling is, student. So this is a homo coupling of aryl iodide. This is exclusively for iodides only. In the presence of copper using a catalyst followed by heating, so we will get the biaryls is the product, right? So for example, student, if X will be iodine, so then the combination percentage of yield will be 93%. If X will be bromide, student, percentile will be 85%. So if the X will be Cl, student, 68%. Because of I is a very good leaving group, so generally the rate of reaction will be more and formation of a product will be very, very high, right? Now look at, students, we will get the biphenyl is the possible product, right? So using a copper as a catalyst followed by heating, right? Now look at, students, so this is nitroiodobenzene, 2-nitroiodobenzene, student. So we will get, student, so this I will be is the better leaving group, student. So now this is NO2. Now similarly this is the radical, student. So it will combining with another compound like this, student. Now this is NO2. Now with undergoing combination, students, we will get the compound 2,2 or 2,2 dinitro, 2,2 prime I can write. So this will be, I can write, student, 2,2 dash. This will be NO2. So I can write, student, 2,2 dash dinitro diaryl or diphenyl. So dinitro diphenyl is the product, right? Now look at, student, so this is iode, this radical will recombining, student. Now look at, so this is the product, this is the radical. Now look at, student, now this is the radical. So undergoing combination, student, we will get the product is like this. Now this will be combining. So we will get the product is like this. Or you can write in different way also, student. You can write the compound is like this also. Maybe examiner want to make like this also. Like this. So this is the possible product, right? Next. So look at, student. So if you reacted with this, student, so yield percentage will be 94. So now this is, student. So Br is the leaving group. Now this will be NO2 and you will get one more compound undergoing the coupling. So this you will get the product. So we can write 4,4 prime dinitro diphenyl derivative. Similarly, student, if we are using, so means here if we are using any electron withdrawing group, student, so generally the yield percentage will be more compared to the electron donating group. So if you are using electron donating group, the what they observed, the yield percentage is less. Right, now look at student. So this will be OCH3 and same student. So this is OCH3. Similarly student, you can use, so this compound will be 91 percentage. One, two, three. This is the possible product. Okay, na student. Now similarly student, some other reaction, copper using metal. So at 210 degrees student. So this H and Cl will leave. So this H and Cl will leave student. So we will get the possible product is this is NH. Now this is the, so here student CNC coupling, CNC coupling student, right? This is again Woolman synthesized in 1903 student, right? So the first compound was synthesized around 1896 student. So then he synthesized some more compound. Here also student, so this H and Br will leave. So here O radical and this Br radical, and it will form as a this type of compound student. So here COC coupling. So COC coupling also he observed by using the copper. Right. This is about student Woolman synthesis student, right? Next. So we will discuss the Schwartz reaction. So Schwartz reaction and Finkelstein reaction student, both are halogen exchange reaction only. So this is a very good for only primary alkyl halides only, right? It is not a very good yield is not possible for the secondary and tertiary alkyl halide. So it is a halogen exchange reaction student. So synthesis of alkyl halides, alkyl fluorides by exchanging chlorine and bromine atom. So in alkyl halides, right, with fluoride, right. So exchange of alkyl fluoride and alkyl bromide with alkyl iodide, alkyl, right, fluoride. So in this reaction students, we are using a fluorinating agent, like you can take, these are the very good fluorinating agents, like you can take AgF, SbF3, Hg2F2, COF3. These reagents are very, very important student. Just you can revise these reagents right now. So this Rx reacted with AgF followed by heating student. So we will get student Rf is the possible product and formation of a byproduct is AgX. Similarly student, you can take CS3Br. So generally we will get CS3F and AgBr is the possible product, right? Now, so CCl3 will be there student. So we will get the final product student. So this will be CF3 is the possible product, right? Now this is about student. So Schwartz reaction. Schwartz reaction is a halogen exchange student. So that is the chloride and bromide is exchanges with the alkyl fluoride only, right? Finkelstein reaction student. This is also halogen exchange reaction student, right? So here we are using sodium iodide in dry acetone student. So sodium iodide is soluble in dry acetone student. So this is alkyl halide reacted with, again you can take X will be chlorine and bromine, right? So this iodine will be displaced student. So this you will get Ri and followed by NaBr and NaCl student. So these are insoluble in acetone and they form as a precipitate, right? Okay, right. So one more important point student. So Schwartz reaction and Finkelstein reactions are very good for primary alkyl halides followed by the SN2 mechanism. Okay, na? Right. Now look at student. So Hell-Vollard-Jelensky reaction we will discuss. Now look at students, Hell-Vollard-Jelensky reaction student. So this is a very important reaction student, examination point of view, right? Now look at student. The HV reaction replaces a CH bond on the alpha carbon of a carboxylic acid with the CBr, alpha bromo bond, CBr bond, right? Means here student, so in this particular reaction student, this is our functional group, right? So this functional group beside carbon is student alpha carbon, right? So this alpha carbon containing alpha hydrogen student, right? Now this alpha hydrogen is replaced by bromine student. So in this particular reaction we will get student alpha bromo derivatives, alpha bromo acids we will get, alpha halo carboxylic acids we will get, student, right? Okay, here you can take the reagent, student, bromine in presence of red phosphorus, student, or you can take PbR3 followed by heating, then followed by the hydrolysis, student, we will get the this compound, student. This compound we are getting as RCHBr COOH is the product, student. This is called alpha bromo carboxylic acid. Alpha bromo carboxylic acid. Alpha bromo carboxylic acid. Now look at the mechanism of this reaction, student. Just look at the mechanism of this reaction. This is RCH2. You can write, student, this is a C double bond OH. Oxygen atom is having a lone pair, student. So this is reacted with PbR3. So this will be the bromine and bromine, student. So it will, in presence of, you can take red phosphorus plus Br2, or you can take, student, PbR3 also. So this will combine, again it will give the PbR3 only. Now it leave the Br minus, this oxygen lone pair will attack to the phosphorus atom. So then it will form a product, student, like this. This is a C double bond O. Then it will form. So this is right. So protonation only, right? Now you can write this will be PbR, student. Now this Br minus is there in this reaction, student, right? Now this Br minus will attack here, student. This Br minus will attack here. This Br minus will attack here, student. This carbonyl carbon. Then we will get, student, this we will get as O minus and Br, and this will be OH plus PbR and Br, right? Now next step, student, so it will leave this compound, right? So then this will be shifted into formation of a C double bond O, right? Now the possible product here, student, this is PbR2OH, PbR2OH, right? Now here, student, we are getting this will be C double bond O Br. So C double bond O Br, right? Now this compound undergoing, student, tautomerization. This compound undergoing tautomerization. This compound undergoing tautomerization, student. This compound undergoing tautomerization, right? So this, right, this hydrogen will be transferred and we will get, student, this will be R. So CH double bond. So this will be OH Br, student, right? So this is the tautomerized product. Now again this is reaction with, student, Br2. Now this will be leave as a Br minus, right? Now look at, student. So just you can write the product is like this, student. So this will be, this bond will be shifted here. Now this will be shifted. Now this Br minus H plus leave as a HBr, right? Now this carbon will get positive charge. Then this Br will be attacks here, right? Carbon will get negative charge, student. This will attack Br. Then we will get, student, this is the Br and C double bond O Br. C double bond O Br, right? Now this is the one possible product, student, right? Now this is followed by water, student, hydrolysis. Then you will get, student, RCHBr COOH. This is our product. So in place of water, student, if you are using NS3, then you will get, student, RCHBr and you will get, student, C double bond O NH2. So amide is the product. So in place of water, student, you can use alcohol, student. Then your product will be RCHBr. So C double bond O, OR prime, student. So you will get the ester and you will get the amide type, and this is, student, acid. So these are the right. Okay, right. So in this particular reaction, student, so why phosphorus or we are using PbR3 is needed for this carboxylic acid, right? So the reason for this, student, here I will give this note point, student, right? So note point here, I will write the one note point here, student, if any space is there, right? Right. So here I will write one note point, student, then after I will erase. So just you can copy, student, this note point. So generally here the phosphorus, why phosphorus or PbR3 is needed, right? So needed for this, right? So because this carboxylic acids do not alpha halogenate. So without using phosphorus and PbR3, carboxylic acid do not alpha halogenated directly. They are not alpha hydrogenated directly because they cannot form enol, so which converts easily acid bromide and so can form enol easily. Right. So without using phosphorus or PbR3, student, generally carboxylic acid do not alpha halogenated directly because they cannot form enol, so which converts easily acid bromide, then they can form enol easily, right? So that's why we need phosphorus or PbR3 in this particular reaction, right? Okay. So this is the note point, student. So just I will paste in the at the end of the page reaction, at the end of the page, student. So just I will copy here, right? I will copy below of this reaction. Just you can copy here, student, right? So now this is the point, right? Just you can copy. Now look at, student. Right. Now some reactions we will discuss, student. So this is CH3CO, right? So this is we can call the propanoic acid, student. So this propanoic acid reaction with this compound, so we will get, student, so alpha compound. So this will be CHBr COOH, student, right? Next, so if we are using this compound, student, so we have alpha hydrogen, student, right? Now this will be compound will be converted into C double bond OOH, and this is the alpha bromogen. So you can do the reaction mechanism also, student, right? So this is our possible compound. Similarly, student, you can use this compound also, right? So this is our possible reaction. Now this is Br will get, student. This is the alpha position, this is the alpha position, this is the alpha position. So this is the alpha position, right? Right. Next, look at, student. So this is also alpha position, right? Now we will get the product is C double bond OH, and this is the Br. Right. Now if you use, student, in place of water by NH3, student, we will get the compound will be C double bond NH2. This will be Br. So in place of water, student, you can use any alcohol. So then here you will get Br and followed by, student, OR dash. Now this is about, student, our HVZ reaction, Helvoland-Zelensky reaction, right? So generally alpha iodoacid is reversible, student, and energetically unfavorable, okay now, right? So fluorine also is we are not using, so because of it is a highly reactive and uncontrollable, over fluorination possible, side reaction takes place, carbon-carbon cleavage possible, and reaction is explosive. Reaction, student, explosive, right? Next, student. So the next reaction is Franklin reaction. So alkyl halides reacts zinc, gives alkane as a product, right? So this is student here, two things you need to remember student. So same, in presence of sodium we are taking zinc metal only student, there is no other point, right? So in presence of absence of a dry ether, right? So generally it is formed as a alkane is a product to student. This point is very very important student. Many of the books this point is not covered. In the absence of dry ether you will get the alkane is the product, right? So in presence of dry ether student, in presence of dry ether it will form dialkyl zinc. So this is organometallic compound, dialkyl zinc. So it is a OMC, organometallic compound. So if you reacted with C2H5Br student, you will get diethyl zinc. It is organometallic compound, right? So this is organometallic compound. So that's it student. So this is about our today's lecture. I hope, I think if the video is useful to you student, so please subscribe the channel and please like the video and share to your friends student. Thank you very much student, and don't unsubscribe student. So please subscribe student. While watching the video, please like student, that is most important student. Thank you very much.